Good evening, everybody.
This is the Unit 2 review for AP Human Geography. We're going to be talking about population and migration. This is chapters 2 and 3 in your cultural landscape textbook. Okay, so let's go ahead and get started by really talking about basics of population. When we're studying population, we're always going to start really at the overarching beginning term, which is demography, which is the study of human populations. Making sure we understand that definition is going to be important. Additionally, we're going to talk about where population is distributed throughout the world. Now, as we've talked about, throughout history, humanity is unevenly distributed. It's not a clear and even spread across the entirety of the planet. As we've talked about, humans are kind of like the Goldilocks of the planet. We can't live in an area that's too hot, not an area that's too cold, too dry, or too wet, or in many cases, definitely not, because any of those situations would be impossible for humans to either live long-term or to grow crops. The area that is fitting in the middle of this is the ecumene. The ecumene being that one separate area where humans can inhabit. Okay? Approximately right now, globally, we're looking at a population of around 50-50. 50% of the planet is living in cities or urban environments. We also somewhat count suburban environments in the cities when we make this calculation. Also 50% in rural areas. This just happened in the last few years, and the number's actually closer now to 51 or 52%. Of the breakdown between LDCs and MDCs, approximately 80% of the world's population lives in a lesser developed country, whereas 20% lives in a more developed country. The largest concentrations, of course, we do need to know the three big concentrations of population. The first is East Asia, and when we talk about East Asia, we're going to talk about China. It's extremely important to recall. The second largest will be South Asia when we're talking about India, and then the third largest will be Europe. And obviously, Europe has had much longer to develop, but Europe, bear in mind, is now decreasing or starting to move lower on the demographic transition, as we'll talk about in a minute. We also need to remember the density formulas, and recall that a lot of these formulas are just mathematical in nature. We need to be able to calculate them and be able to interpret what each of these means. Now, density itself is just the number of people per particular land area. We have different kinds of densities that we have to keep in mind. The first is arithmetic density. Arithmetic density, very simple. Total people divided by total land area. Nothing special, nothing too crazy. Physiological density gets to be a little more complex. Physiological density is the total people divided by the units of arable land. This is typically a track of how much a society is going to be able to provide for itself agriculturally. If a country has a very low physiological density, meaning very few people per units of arable land, that's typically a sign that they're going to have enough land to feed their populations. However, a very high physiological density, like a country like Japan, is going to find themselves needing to have to import more food or to find more food from off-land choices, which is one particular reason, additionally, that Japan is so very dependent on seafood and fish as part of the diet. Agricultural density is the final. Agricultural density is the total number of farmers divided by the units of arable land. Why this is important is that if there are more farmers, typically they're going to be involved in more sustained subsistence style farming, not market farming like we'll find in the United States. So, just to recap, high arithmetic density, very dense population. Low arithmetic density, obviously very non-dense population. Physiological density, again, the higher that area is, the higher that number is, the more reliant on importing food, the lower, the less reliant. And then for agricultural density, the higher that density is, the more subsistence farming that's going on. The lower that density is, the more market farming that's going on. Okay, so when we're trying to calculate what the globe's population is, there are two real formulas we look at. The first is the Global Demographic Accounting Equation, which sounds really, really complex, and it's not even close. It's very simple. Our new population will equal our old population plus the number of births minus the number of deaths. Seems pretty reasonable. Now, that's looking at the entire planet. But let's say we wanted to look at a region or a smaller scaled unit, such as a city. To try and figure out a city's population and how it changes, the new population will be equal to the old population plus the births and minus the deaths. But now we also add immigrants, remember immigrants, people moving into an area, minus emigrants, people moving away from an area. Okay? Remember that the regional only adds that nice little two immigrants minus emigrants at the end to make sure you know the difference between the two. Carrying capacity. We didn't discuss carrying capacity as much in class, and we'll get into it a lot more when we talk about agriculture unit in Unit 5. But what you should know about for right now, carrying capacity is the number of people that an area can either sustain or support. It's going to depend on multiple factors. It's going to depend on available space. If society doesn't have a ton of space, a city like Hong Kong or Tokyo where there's not a lot of room, that's going to have an impact. Also, more technology means that they can increase more food capacity. They can create more better housing for people to live in. Better wealth, better climate, better ability to bring in resources. It kind of extends the carrying capacity of a nation. The problem is carrying capacity is also very closely tied to a country's economic abilities. So if countries aren't well off economically, they're going to have a very hard time carrying a very high carrying capacity. Now, when we talk about overpopulation happens when our population exceeds our carrying capacity. If the sign in the pool says bathing load 100 and you put 200 people in the pool, bad things are going to happen. So the whole idea of overpopulation is making sure we understand that we have to meet our carrying capacity or raise our carrying capacity in order for it not to be an issue. Population pyramids. I know y'all enjoyed reading and trying to figure out and interpret what these look like. But again, these are graphics that show the distribution of population both by age, which you'll see from top to bottom, and by gender, typically women on the left and men on the right. Remember that each one of these bars represents a group of 5-year-old cohorts. So the bottom cohort is from 0 to 5, then 5 to 10, 10 to 15, and so on and so forth. Okay? Remember that the bigger and more like a pyramid that it looks like, the more likely that they're a stage 2 style country. But that the closer to a cylinder it is, the more of a stage 3 or 4 country it will be. And then, like the one you see off to the right here, when you have a increasing almost like a vase shape, it's more of a stage 5 country. The population pyramid you see to your right now is actually for a stage 5 country. Now, the dependency ratio is something we'll be able to calculate by looking at a population pyramid. It compares those who are in the workforce with those who are not in the workforce. When we talk about population pyramids and dependency ratio, remember we used an example in class of the Oreo cookie. Nobody buys the Oreo cookie just for the cookie. No offense, Nabisco, that's just the way it goes. People buy the Oreo cookie for the cream filling. So, if you think about it, we'll take the mouse out here for this, the bottom cookie is that 0 to 15 range at the very bottom. The top cookie is our 65 and older population. Both of those cookies are going to be supported by the cream filling. That's ages 15 to 65, those people who are in average working age. The larger that ratio, the more people who are being depended on for that a particular age group. So you have to be careful. Remember, think about the Oreo cookie example when we remember dependency ratio. There are some key measures of demography, and there's a lot of math and a lot of acronyms, so please make sure we understand clearly what each of these acronyms possibly means. The very first off is CBR, crude birth rate. Now remember, when we use crude, that term just refers to a very, very simple measure. We're not talking about anything too complex. To measure the crude birth rate, all you have to do is count up the number of live births in a year and divide it by 1,000 people. Okay, so for example, if we were to count up the number of live births in a community, for every 1,000 people there were, say, 4 or 5 or 6, that gives you an idea. So it's the number of live births
divided by 1,000 people. Crude death rate is going to be the same idea, just take the births out and replace them with deaths. Very simple. To figure out our natural increase rate, or our rate of natural increase, and you'll have to be careful because they do like to interchange those two acronyms. That's found by taking our crude birth rate, subtracting our crude death rate, and dividing it by 10. That number itself is a percentage. So whatever pops out of our NIR calculation is a percent. Infant mortality rates. IMRs are the number of infant deaths. That means children dying under the age of 3 divided by every 1,000 live births. The higher an infant mortality rate is, typically we have lower economic progress as well as more significant problems. Life expectancy. Life expectancy is very simple. It's based on an average life expectancy for all the people living in that particular area. As we've discussed with countries like Russia, where you have a big gap between life expectancy for men and for women, you always have to take those things into account. Okay, so life expectancy, very simple, just calculate the average. For fecundity, okay, fecundity is the ability of a woman to conceive. That is a term that gets kind of tossed around in demography that you might need to be able to understand. The lower that rate is, you have significant other health issues that have to be taken into account. Then there are two types of fertility rates, general fertility and total fertility. General fertility is for the number of births divided by every 1,000 able to conceive women, or 1,000 fecund women. Okay, so if there are women in society who are unable to give birth, they would fall out of a general fertility rate. However, general fertility rate isn't typically something that gets used. We usually use total fertility rate. Total fertility rate is the predicted number of births that each woman will have in their entire lifetime. In order for a country to meet replacement level fertility, meaning that the next generation will have the same number of people as the current generation, the total fertility rate has to be somewhere between 2.1 and 2.5 children per woman. Now, the higher that number is, obviously, the higher the birth rates and death rates, and therefore the higher the rate of natural increase. The lower those rates are, like what we're seeing in stage 5 countries, is we're seeing replacement levels under 2.1, which is having the impact of reducing the number of people in that particular area. Don't forget, we're dealing with a population explosion currently. Okay, we are currently growing at an exponential rate. Our current rate of increase is approximately somewhere in the every 35 years range, if we maintain current rates. You always need to understand the historical trends that have led us to this point, where we started with the first agricultural revolution, which started people to settling in areas. These settlements turned into cities. The cities eventually start to develop industrial abilities, which leads to the second agricultural revolution, which leads to kaboom, there's your population explosion. Don't forget about Malthus. And I'm making a bad joke, of course, on the slide, but let's pretend to be shocked that I'm making a bad joke here. Malthus's theory, remember, was that the population was growing exponentially, so that the first generation would have 1, then 2, then 4, then 8, then 16, while food was growing arithmetically. So in the first generation, you'd have 1, then 2, then 3, then 4, then 5. By those calculations, by the time you reach the 5th generation, we have 16 people, but only enough food to feed 5. The problem with this is that Malthus didn't quite get it. He was looking at the entire situation through the lens of the Industrial Revolution, where we were still seeing huge levels of growth in population. As we know now, Malthus's ideas were right for his time, but wrong for the present. So we have the Neo-Malthusians. Neo-Malthusians who are still looking at this situation say, he might be right, but mainly in LDCs, not in the rest of the world. Remember, though, the key is don't go past your carrying capacity. If it says only fit 3 people in this area, don't try and fit 4. Okay, policies that you need to be aware of. You need to be aware of both pronatalist and antinatalist policies. We've talked about both in class. Pronatalist policies are policies that we're going to attempt to expand the population. The government is basically promoting reproduction and bigger families. We talked about Russia and Vladimir Putin and young Russia's policies of trying to get women in Russia to produce more children, giving them economic incentives, saying that if you give birth on this day, you're going to win a free car. It's like the baby is right. Then you have antinatalist policies. Antinatalist policies are much more restrictive. The government's now discouraging reproduction and wants you to have smaller families. For example, China. Oh yeah, China. The one-child policy. We've already talked about the results of a one-child policy in China. They're going to have some significant demographic problems in the next generation. So, bear in mind that not every antinatalist policy turns out well. Our projections right now kind of come into three big bands. There's the low-growth perspective. The low-growth perspective says that not only will we kind of peak out in the next few years at about 7.5 billion by 2050, but that we'll actually start to reduce our population by about 2100 to about 5 billion, which is about where we were in the early or the mid-20th century. Then there's the high-growth projection. The high-growth projection says that by 2050, we will have reached 11 billion people, and that by 2100, 16 billion. But most people are kind of locking into this medium growth projection that says that by the year 2050, the world will have reached 9 billion people and will start to steady out over the next few years after that, reaching about 9.5 billion. Where we'll fall in these bands depends on a lot of other issues, especially having to do with the demographic transition. Some miscellaneous stuff that comes kind of into play when we talk about populations. Don't forget about epidemics and pandemics. We've given you guys some notes on epidemiologic transition. If you remember that chart we created in class, which I don't have a copy of in front of me, use your chart. Make sure you understand what epidemiologically will happen at each stage of the demographic transition. But you need to also remember the difference between an epidemic and a pandemic. An epidemic will happen at a more local region. If, for example, everybody at school catches the flu at the same time, you might call that an epidemic, although it's a very local region. But then you have pandemics. Pandemics will affect large numbers of people at a global level. The key is that it's going to be people in very different areas of the world and at different age groups, economic groups, etc. Don't forget the difference between the two. It's all about scale. Demographic momentum. Demographic momentum is going to occur in a lot of underdeveloped countries once the population keeps growing after reaching replacement fertility. So a country like India, even though they might eventually reach 2.1 for their total fertility rate, which is technically replacement rate, there's still too many people in the society. It's going to take a little while to slow it down. It's just kind of like when you take your foot off the gas pedal of the car, it takes a little bit for it to slow down. So right now you have to wait for the momentum to slow itself down and bring it back down to a reasonable growth rate. The demographic transition model. You should have a notes page that we have already drawn out this entire model. So I shouldn't have to go through this too much and extensive because we've spent about 3 or 4 class days on it. It is that important. It will be on the test, and it will be something that you will see again on the AP exam this May. Looking at this demographic transition model, let's just do a very quick run through. If you look at the red line at the top during stage 1, remember that the red line is our birth rate, the blue line is our death rate, and that eventually, as we move through the different stages, you'll start to see the red lines and the blue lines come closer together near stage 4. The green line is our population itself, and you'll see how much population grows throughout stages 2 and 3. And then the last line, which looks kind of orangish. I can't tell from here. Can't really see it very well. You'll find this figure in your book, by the way. That's our natural increase rate. It gives you an idea about how fast our natural increase rate goes. But you'll find that, oddly enough, it doesn't go that far above 1 or 2 globally. Now, beyond that, there are other rates of natural increase. To recap, our 4 major stages and technically 5 possible stages of the demographic transition. Stage 1 is our low growth, high stationary stage. CBR is high, our CDR is high, and because the two are high and continuing to fluctuate, our rate of natural increase is low. Because remember, if CBR and CDR are equal, we're not growing a lot. Tons of famine, tons of disease, war, low life expectancy, there's no medical care, but when medical care finally improves beyond let's throw a leech on it, we're getting to stage 2. Stage 2 will see a declining death rate. When we have high birth rate, declining death rate, the natural increase rate is going to go through the roof. Medical care is going to extend people's lives, and because their lives are going to be longer, the problem is, though, they're still subsistence farmers. They're still only growing enough food for themselves. It's hard for them to adjust quickly. Instead of saying, I don't need to have 10 kids anymore, knowing that half of them are going to die, now I keep having 10 kids, and now I can't take care of them all. Conditions get a little too tough culturally and economically. So when this starts to happen in stage 2, people start to pare back their birth rate. This helps us lead to stage 3. Stage 3 is moderate growth. Your birth rate is declining. Your death rate's actually stabilizing. It's still going down a little bit. What this leads to is that our rate of natural increase is actually itself slowing down. It's like we're taking the foot off the gas pedal and we're just cruising to our destination. Conditions change, families follow suit. They start to slow down and they're not quite as big as they used to be, having less children than before. Industrialization, improved health also increases life expectancy, improves general welfare. You're having people live longer, better lives. The more they modernize, the better off they're getting. They eventually reach stage 4. Stage 4 is low growth, low stationary. Birth rates are low, death rates are low, and as a result, just like in stage 1, our rate of natural increase is low. The population is stable, much more modernized, more focused on the industrial or service industries. Remember, we have some theories about the existence of stage 5, and I've given you that detailed information on your demographic transition model notes, so please go back and refer to them. This is all based on the graying, or the getting older, I suppose, of stage 4 populations. We'll talk about stage 5 again later in the course. The epidemiologic transition model was also on those DTM notes. The ETM focuses on identifying and explaining the causes of death at each stage of the demographic transition model. In stage 1, it's the age of pestilence and famine. Not enough food, plus no sanitation, plus no medical care equals bad days. Life expectancies in the 30s and 40s, people not living terribly long lives. In stage 2, with the increase in medical care and even some increases in sanitation, pandemics are no longer the issue they once were. And so as they recede, things get a little better, life expectancy increases, famine's still occasionally a problem. In stage 3, we're in the age of degenerative and man-made diseases. These are diseases like heart disease and HIV and AIDS, which we're starting to see, and cancer. Heart disease is much more of a man-made disease than it is anything else. And cancer is something we're still fighting for. But in stage 3, we're dealing with much more degenerative diseases, as a lot of the pandemics, which are the sudden killers, aren't any longer the big deal. Stage 4 is the age of delayed degenerative diseases. If you're living in a stage 4 country, again, and are diagnosed with cancer, you're going to live a lot longer than if you're in stage 2 country. Same thing if you have heart disease or if you're diagnosed with HIV and AIDS. You're more likely to live a longer life living in a stage 4 country because we have the medical care and ability to take care of those issues and therefore give the opportunity to live a longer life. Okay, a few things that we've kind of discussed as we're starting to lead into migration. In Unit 1, remember we talked about space-time compression? Space-time compression, the whole idea that over time, things are getting closer and closer and closer together. It's kind of the ideas of globalization. Distance isn't changing, but the methods we have to bridge that distance, either technologically or by me putting out a video for your Unit 2 review, or by just being able to pick up the phone and call someone halfway across the world, or being able to cross the ocean in 5 hours. These are methods that we can bridge the distance a lot closer. What this leads to is something called friction of distance. Friction of distance is the difficulties we face in overcoming spatial and temporal barriers. The less of those difficulties we face, the lower the friction of distance. Okay? So you have to always take that into account. So if you're ever asked about friction of distance, take into account the kinds of situations that the people involved in the question might be facing. Do they have access to the internet? Do they have access to global travel, especially via airplanes? If they do, friction of distance might not be as big a deal. Spatial interaction. Spatial interaction is the interaction between two places, usually through communication or economic transaction, but in this unit, it's specifically talking about migration, when people are moving from one place to another. That's a spatial interaction. We wind up seeing these things happen over and over again throughout geography. Migration, big piece, part two of the unit. Migration is a permanent, not temporary, not I'm just going to move down there for the summer. No, permanent moving of your home region and crossing the border to a new region. As we talked about over the summer when you guys read Power of Place, not everybody's going to do this that frequently, so migration is not as common an issue as you think. We need to understand push and pull factors. Remember that push factors are the reasons, the negative influences that make a person want to move away. It can have to do with the taxes, the economy, the crime rates, abuse of governments, genocide, human rights violations. It really depends on the situation. The pull factors are positive influences that pull a person towards a particular place. When we talked about why you might have chosen to move to the area you live in now, it might have to do with a better economy, more affordable real estate, good schools, clean parks, better jobs. It's usually an economic issue. So when we remember the push and the pull factors, the most common ones we need to think about are the economic pull factors. The reasons why people move are usually economic in nature. The reasons why people leave, either because they're seeking a better opportunity or culturally they're being forced to. There are patterns to be followed, and the pathways from origin to destination are called migration streams. There are some general migration streams that we see in the world today. Things like the idea of moving from New York to Europe, to New York from Europe in the early 20th century. When you're talking about people coming in through Ellis Island, this was a migration stream. Today, another one of those migration streams has to do with movement into the United States from Mexico. If a place has more people moving in than out, then they have a net in migration because more people are living into that area. If they have more people going out than in, they have net out migration. Now, for every migration stream, there also could be a migration counter stream. People who are going back to where they came from. This does not happen as often as you might think, but it's important to know the terms. Okay, types of migration. One of the most important types that we've talked about is the idea of chain migration. It's when people migrate to be with other people who migrated before them and with whom they feel some kind of linkage. One of the frequent ways we see this in the United States is when you see one person from a family migrate to the U.S. with the express purpose of trying to earn money to send back to their family as a remittance, but then earning enough money to bring the entire family with them to the United States. There can be other reasons why chain migration happens. It can be family, it can be cultural, it can be religious, or it can be ethnic. When we start to see in large cities population clusters of people from particular communities, this is a result of chain migration. Now, we should hopefully not need to go into the difference between voluntary and involuntary migration. It's just as simple as knowing the words. But do remember this. Voluntary migration is almost always a result of people seeking a better economic situation. On involuntary migration, almost always has to do with people trying to get away from a bad situation. Don't forget that, especially because involuntary migrants are also known as refugees. We'll get to that in a second. Do know the difference also with internal migration and the two types of internal migration. Internal migration is when you're moving within a country, like moving from Florida to New York or New York to Florida or vice versa. Inter-regional migration is when you're moving from one region to another, but intra-regional migration is moving within a region. As we've talked about when we discuss inter-regional migration, one of the most common streams in inter-regional migration is the idea of moving from rural to urban to suburban, with the occasional move back to rural as a result. So, don't forget about that possibility. Refugees. A refugee is a migrant who's fleeing some form of persecution or abuse. Typically, they're coming from a country with a negative political system, or they're being targeted, or they're otherwise just in a bad situation. They're fleeing some kind of persecution or abuse, and they're therefore trying to seek asylum in a new country. Remember that the United States accepted a lot of refugees who were coming out of communist countries during the 1960s, 70s, and 80s as a result of, for example, Cuba becoming a communist nation. You should be aware of current refugee situations in several regions of the world. because they're going to continue to be important, and they could come up as examples for either multiple choice or free response questions. Those regions are Sub-Saharan Africa, the Middle East, pay attention to Syria right now, Europe, Southeast Asia, and South Asia. The most pressing refugee situation in the world right now is actually in Syria, flooding into Turkey, Lebanon, and Jordan. And as a result of those refugees, you're seeing a lot of pressure on those countries to try and do something to end the situation in Syria. Don't forget, you also need to know the three major waves of migration to the United States. These three waves of immigration, the first, again, was the colonial era, from around the 1600s through 1776, and actually even up to the Civil War. That immigration was from Europe and Africa. The Europeans were migrating voluntarily, the Africans, not so much. The second major wave of immigration was in the 19th and 20th centuries, from about 1840 to 1920. The first two peaks of that immigration coming from Germany, Ireland, and later on from Norway and Sweden. This is why you see a lot of those populations, especially in a lot of the influence of those cultures, in Ohio, Pennsylvania, Michigan, Wisconsin, Minnesota, and throughout. The third wave, the current one, is from Latin America and Asia. That's the current wave we're currently in. We're seeing that it might be starting to taper off, but again, we'll see. Now, why people decide to migrate typically fits into a pretty predictable pattern based on a few factors. The evaluation of how likely someone is to migrate, it's called migration selectivity. This wasn't something that was directly covered in your text, but the big ideas and the big factors behind somebody choosing to migrate usually have to do with their age, their gender, and their education level. Don't forget about brain drain. We'll come there in a second. We'll also talk about brain gain, which is kind of the reverse, if you think about it. Brain drain, all the smart people are leaving. Brain gain, all the smart people are coming back. Good stuff, right? Okay, Ravenstein's migration laws. There are 11 total generalizations. We can't call them laws because we can prove them somewhat wrong. But here are the important ones that you should understand. Most migrants will travel a short distance, going in step migration, trying to achieve a long-distance goal in small steps. Another one, migrants who are traveling a long way tend to move to larger cities than smaller cities. When a person immigrates to the United States, you're more likely to find them in a large city, at least for the first generation. The second generation beyond might find their way outside of the city. Rural residents are going to be more likely to migrate than urban residents. You'll start to see that movement, rural to urban, especially in stage 2 countries. Families are less likely to migrate across the national border than a young adult. Typically, as we talked about when we watched that one film about cash flow fever, you're seeing in El Salvador a lot of young people, especially between the ages of 16, 17, and 18, all the way up through their mid-30s, migrating across national borders, earning money, and sending that money back to their families in their home country. This is the idea of remittances. Okay? And last but not least, just like in physics, every action has an equal opposite reaction. Every migration stream can create a counter stream. How strong it is also depends. We haven't talked about the gravity model as much. We were going to, but we went ahead and canceled that lab and focused on a couple other things. The gravity model is something that estimates spatial interaction and the movement between two places. If you think of the idea of gravity, that something is going to be attracted to a source of gravity, it just predicts that larger places attract more migrants than smaller places. If you think about this, a city like New York is going to attract a lot more people than a place like Ponte Vedra or like St. Augustine. You don't see a lot of people emigrating to St. Augustine, but you see a ton more emigrating to New York. The larger the city, the more people go there. Just as large planets have more gravitational pull, same idea. It also predicts that closer places will attract more migrants than distant places. They're more likely to go somewhere that's kind of close than somewhere that's terribly far away. Okay. Wilbur Zielinski and his model of migration transition. This time we're attaching migration to the demographic transition. Again, check your DTM notes. People from stage 1 countries, do we have stage 1 countries? No, but they move just far enough to get what they need. Hunters and gatherers, basic settlements. People from stage 2 countries If they're moving, they're doing one of two things. If they're moving in their country, they're going rural to urban. If they're moving out of their country, they're going to stage 3s and stage 4s in search of what they might need. In stage 3 and 4 countries, if there's going to be migration, it's usually interregional. Urban to suburban usually is the main movement. The other kind of migration you might see is from stage 3 and 4 countries to other stage 3 and 4 countries, typically in search of better economic situations. All right, temporary movement. Temporary movement is, bear in mind, a couple different types. We have cyclic movement, which is daily routines. If you remember Concha Martinez that we watched in Power of Place, who was crossing the border on a daily basis just to sell cigarettes on the other side, on the American side of the border. That was a daily routine kind of movement. We have people all over the world today who cross a border just for work. It's a daily routine. It's not a permanent movement. There's also seasonal movement. Seasonal movement. It's when you're moving in response to the change in season. We have some people, and I have a good friend, who actually moves to Panama every summer. Why? He has a house there and he wants to. He has the ability to do so. That is a seasonal movement. Then you have periodic movement. Periodic movement is a longer period of stay, such as a college or military service. A lot of people come to the United States to attend a college or university. This is a great example of periodic movement.